So the next one says, for a river flowing west with a current of 1.2 meters per second, so same river, and a swimmer decides she wants to swim directly across. So she wants to start and finish directly across from the shoreline. If she can swim with a speed of 1.8 meters per second, find the angle at which she must direct herself and the time it takes her to cross the river if the river is 200 meters wide. So I just drew the same river. So we have our same river, same distance, but here, and I have the same current. So I want her to start and finish directly across from the other one. So since she flowed, if she just swam, she would flow kind of northwest. She now needs to swim in which direction to counteract the current? Needs to go east. So this is just a distance vector, but the direction she will actually swim, okay? So the actual person will swim northeast, right? You agree with me? Okay, so we'll draw that vector. This is not the vector diagram. This is just setting things up. So since the actual person is swimming in that direction, that vector gets her speed that she can go at. So this vector gets 1.8 meters per second because that's the direction the swimmer is choosing to go. You see that? She's choosing and making the intentional movement that way. So, and she can only swim 1.8 meters per second. That's how fast her body can go. So that's why we choose to put it on that vector. Are you with me? Yeah? Okay. So now let's put it together and make our actual triangle. So we have our distance is 200 meters, I know. And, oh wait, I'm going to draw this. No, I'm not. So overall, she's going to go this way, and the current is going this way. Okay. So does that clear up why I choose to put certain things on certain vectors? Yeah, I hope so. Okay. So next it says to find the angle at which she must direct herself. So since she's starting here and going in this direction, this is my angle that I need to find out. So I need to use the same units whenever you're kind of doing your sine, cosine, etc. So I'm going to use this information here. So my opposite over hypotenuse, which will be sine. So sine theta is equal to opposite over hypotenuse. So theta is equal to inverse sine of 1.2 over 1.8. So theta is 41.8 degrees. This question is to 2 sig digs, so I'm going to say, so the angle, I can spell angle, the angle is going at 42 degrees east of north, or 48 degrees north of east. The time so that's for part A. That's the answer for A. Next, the time it takes her to cross if the river is 200 meters wide. Okay, So I need to know my V, my D to find my T. Well, this is the only side that I know my D at. So what can I do now?
Figure out your V on that side.
Yes. So I need to figure out my V here using Pythagorean's theorem, using my a squared plus b squared equals c squared, and then you can find your T. So we know a squared. For this though, remember that your c squared is your hypotenuse, so you have that. So a squared will equal 1.8 squared minus 1.2 squared. Can someone tell me my a when they get it? 3/4? 1.2.
1.3416.
Okay. So that's my V for all my, what is that? This is still my vertical vector. So I will say V is equal to 1.3416. I know that my D is equal to 200 meters. T is equal to D over V. What is it? 140. 149 seconds, so to sig digs, our T is equal to 1.5 times 10 to the 2 seconds.